Hello everybody. We'll continue looking at more properties about triangles. We'll jump into lesson 4.2 here, which is the Triangle Sum Theorem. One of the most fundamental concepts when it comes to triangles and their properties is that the three angles of a triangle will always add up to 180 degrees. In this particular picture, the measure of angle A combined with the measure of angle B combined with the measure of angle C has to total 180 degrees. It is a guaranteed fact. And to prove it, we are actually going to tackle example 1 here, which is the formal proof of how a triangle sums up to 180 degrees. So as we read through this proof here, the statement is, if a figure is a triangle, then the sum of its angles is 180 degrees. We are given that this dotted line, XY, is parallel to the one down here, AC, and as a result, prove that angles 1, 2, and 3 inside the triangle add up to 180 degrees. So, statement 1. To write any formal proof, we do have to start with what we've been given. So, segment XY is parallel to segment AC, a true fact because it was given to me to start the problem. Now, let's go back and think about what we've seen in previous chapters. Parallel lines that are cut by a transversal create several different angle pairs that we know properties about. Specifically, we're going to focus on this angle up here, which we're going to give an extra label 4, and this angle over here, which we'll give the extra label 5. What we're going to argue is 4 and 5 match up to 1 and 3 because of parallel lines and transversals. And then we're going to say that 4, 2, and 5 is the same as 1, 2, and 3 because we know what 4, 2, and 5 are going to become. They are the three angles forming this dotted line on top. They are a guarantee to add up to 180, and that's going to be what puts our proof together for us. So let's build each of these steps along the way here. From the top of the picture up here, we have this dotted line, so we can claim that the measure of angle 4 added to the measure of angle 2, added to the measure of angle 5, will be 180 degrees because they are literally adjacent angles forming a straight line. You may think you want to put linear pair in that reason, but you need to realize it's 3 angles, not 2. So it's the linear pair concept. We just can't say pair because it's not 2 angles. So you got to be a little more descriptive. They are adjacent angles combining together to form that straight line. Now we've got almost what we want. Angle 2 is in the correct place. It's in the middle slot. We just need to turn angle 4 into angle 1 and turn angle 5 into angle 3 and we'll be done. So let's actually argue that. We'll claim that angle 1 is congruent to angle 4 because these are a pair of alternate interior angles. Thank you, parallel lines. So alternate interior angles, but that's not the only pair that we have. We can do the exact same thing for angle 3 and angle 5 on the other line that's cutting through them. We get the same reason just because there's 2 different spots where it's happening. Now that these angles are congruent, let's use the definition of the word congruent. If the pictures are drawn congruently, we know their measurements have to be equal to each other. So we'll write that for the next 2 lines here. The measure of angle 1 equaling the measure of angle 4, and the measure of angle 3 equaling the measure of angle 5, because that is what the word congruent truly means. If pictures are drawn congruently, then their measurements must be equal to each other. At which point now we get to go trade out things that are equal. In place of angle 4, we're going to place the measure of angle 1. We're going to leave 2 alone because I liked it. It was in the middle spot. It's what I wanted. And we're going to trade out 5 and put angle 3 in its place. At which point we've now stated that the measures of angle 1, 2, and 3 added together add up to 180 degrees. All I need is the property that allows me to trade out things that are equal, and that is the substitution property. Substitution. At which point, that is what we've been asked to prove, so my proof is done. I don't need lines 8, 9, and 10. All I had to argue was alternate interiors trade out the angles that are inside the triangle for the ones that are up here on this dotted line at the top that was parallel to begin with. That's it for the formal proof. As far as actual practice and problems, you literally just set up basic equations that total 180 degrees. So for example, let's take a look at 2 and 3 down here at the bottom of the notes. If we start with this triangle that's on the left, angle 1 combined with 66 combined with 84 must be 180 degrees because they are the 3 angles forming a triangle. Now a little bit of simple arithmetic. We'll go combine the 66 and the 84 together for a grand total of 150. And then basic algebra will subtract that off. Our missing value for angle 1 must be 30 degrees. And we've got one of the 3 answers done already. Now, one of the keys to remember, you're seeing a new property and using it in triangles, but that doesn't mean that old thoughts disappear. We can solve for angle 3 immediately because these are a linear pair. 84 and 3 are side by side, making up the bottom line of the triangle. So right off the bat, we can take care of this one and have angle 3 done. If we subtract that 84 off, we'll find that the measure of angle 3 comes out to be 96 degrees. Which now puts me in the second triangle, the one that's on the right. Angle 2 combined with 43 combined with the 96 that we just found for angle 3 must also add up to 180 degrees. They are the 3 angles of the right side triangle. Again, we'll add up our like terms here. We've got a 43 and a 96, which is a grand total of 139. And if we subtract that 139 off from 180, we'll end up getting that angle 2 is equal to 41 degrees. So our 3 angles are 30, 41, and 96 respectively. The key to every one of these triangle problems is nothing more than build a 180 argument in some manner. Either the 3 angles of the triangle or 2 angles side by side if you have to cross over to another triangle. But there's lots of 180s to be found, lots of clever tricks to put into the problem. The bottom one down here, same idea. We're going to combine the 3 angles together, except this time they're all given algebra expressions. That doesn't change our work at all, it just changes how much work we're going to end up doing. Angle D, 5x minus 2, combined with angle E, 9x plus 3, combined with angle F, 11x minus 21, must total 180 degrees as they are the 3 angles of a triangle. That fact puts everything together for us. So now, like terms, if we combine the variables together, we have 5x and 9x, which will be a total of 14, plus 11 more, creates 25x. We have a negative 2 and a positive 3, that's plus 1, minus 21, so we end up at minus 20, still equaling 180. Now perform your algebra. Add the 20 to both sides. That creates 25x equaling 200. And then we'll divide the 25 out for our value of x to end up being 8. And that is all I was asked to find, was the value of the variable x. As with all the problems you've seen throughout the year, you could also be asked to go back and find one of the angle measurements or even all of the angle measurements. You would just simply plug that 8 in if the problem asked you to do that. If you've got any questions, make sure to ask your teacher as you go through the practice problems, and see everybody in the next section.